Assume that the Poisson distribution applies and that the mean number of hurricanes in a certain area is 8.1 per year. So what it's telling us here is that we can say that the mean is 8.1. So we know that the mean is given as 8.1 per year. Now we want to find the probability that in a year there will be 7 hurricanes. So 7 hurricanes means that we want to find out what is the probability that x is going to equal 7. Now, to find the probability of an event occurring x times over an interval, use either technology or the Poisson probability distribution formula given below, where E is approximately 2.71828 and the mean is the mean number of the occurrences of the event in the intervals, which is given as 8.1. Now here is the Poisson probability formula. So if we wanted to find using the formula, we would say, okay, the probability of x being 7. So we have the mean, which is 8.1, and then we would raise it to the power of x, which is 7. And then we're going to multiply that by E, which we know is the value of 2.71828. So let's go ahead and write that in there. So we have times 2.71828. And then we're raising it to the power of the negative value of the mean, which is 8.1. And then we're going to divide that by x factorial, which is 7 factorial. Okay. Now, if we wanted to use our calculator, and I'll show you how to use this on the calculator, okay, we would do the following. Okay, we know that we need to take parentheses 8.1, and then we're going to raise it to the power of 7, and then shift down, and then multiply that by, again, parentheses 2.71828, and that's to the power of, make sure you use the negative symbol, negative 8.1. Okay, so there's our result. Now what we need to do is we need to divide it by 7 factorial. So we'll put 7, and then we're going to go to math, and then scroll to the right where it says PRB for probability, and then go all the way down to 4. And then hit enter, and then we're going to put in our answer there, and then we're going to compare it to what it would look like on StatCrunch. So here is our result by using the calculator. Now, if we wanted to use StatCrunch, we would have to select Stat, highlight Calculators, and then select Poisson. And then in the dialog box, we're going to enter the value of the mean, which is equal to 8.1, and then we're going to put in the value of x, which is equal to 7. And again, what we want to do is find the probability that in a year there will be 7 hurricanes. So the probability of exactly 7 is equal to the probability of x is equal to 7, and then we're going to select compute. So I'm going to open up in StatCrunch, and so now what I want to do is I want to go to Stat, Calculators. Now I'm going to scroll all the way down to where I see Poisson, and then I'm going to put in the mean. We know the mean is 8.1, and we know that x has to equal the value of 7. So let's go ahead and then copy that. So as you can see here, very similar to what we have up there. Now it might be slightly different because you can see here we have 0.13777781. This is 0.1377778565. Now the reason why this one looks different than this is because what we're doing is the value of E, we truncated it at 8. But when you're using StatCrunch, it doesn't truncate it, it keeps going. So that's why this is going to be a more accurate number than this one. But even though, if we want to round it to a certain decimal, we're going to round it to 3 decimals. So if we round both of those to 3 decimals, you can see that if we round this to 3 decimals and round this to 3 decimals, we end up getting 0.138. So therefore, the probability that in a year there will be 7 hurricanes is 0.138. Now in part B it says, in a 65-year period, how many years are expected to have 7 hurricanes? Now, to find the expected number of events in an interval, we multiply the probability of the event in a single interval by the number of intervals that the larger interval is composed of. So, there are 65 one-year intervals in a 65-year period. The probability of the event in a single interval 1 year was found in part A to be 0.138. Therefore, in a 65-year period, the number of years, rounding to 1 decimal place, that have 7 hurricanes is expected to be the following. We're going to take 0.138, which is the probability that was found in part A, multiply 60 by 65, and we get 8.97. And then we're going to round that to 2 decimal places, and therefore we get 9.0. So therefore, we get 9.0 is the expected number of events in the interval. Now, how does the result from part B compare to a recent period of 65 years in which 9 years had 7 hurricanes? Does the Poisson distribution work well here? Well, the result from part B was 9.0, which is close to the number of hurricanes in the recent period of 65 years. So we would say that the Poisson distribution does appear to work well in the given situation.